question. So yeah, just as a reflection, dilated first, bigger than 1 makes it dilated, narrower. If it's between 0 and 1, it makes it wider compared to it. This will then reflect it if it's negative in the x-axis. So if it's negative, it will become unhappy. So if it's a negative graph, you should be able to see it's, I remember as a negative graph, it's negative, and that means it would look like that, and it will have a maximum turning point. Whereas if it's positive, that would be like a negative x squared thing. If it's a positive x squared thing, it would be like this. And these are the notes we went through in the last lesson. Then we've got translations. This moves at the opposite way you think, left and right. So that would move 4 units to positive. When I'm saying this, we're talking about where the turning point goes, okay? And that moves at the way expected. So, that would be like 4, 3. That would be a negative 1. So that would be 4, 3 over here. Okay. It'll be positive 4, 3, not negative, by the way. Okay, so that's sort of where we're going with that. So just as a quick review, that's where we're going. And let's have a look at the rest of this. So how do we find the y-intercept? Remember, we want to find the y-intercept. We always let x equals 0. So we put 0 into this equation. You're going to have 4 squared is 16. 2 times 16 is 32. Minus 3 is 29. So it's at 0, 29 would be where it is here. And that's how you can get that graph. We know it's positive. Therefore, it's going to be that shape. And that is a very bad shape. That's a quick graph. Let's move on. So today we're going to look at completing the square. And then once we've completed the square, how we can then graph that and find the x-intercepts. So the first thing I'm going to start off with, I suppose, is finding the x-intercepts. So let's just put out a question and we'll try and find the x-intercepts on this. So we're going to have y equals, let's go with 2, x plus, let's go 4, why not? Let's go with minus 11. Let's have to think about that one. Okay, so with this question, first of all, let's think about where the turning point is going to be and what's happened. So we always start off with our dilations. It's been dilated by a factor of 2 from x-axis. So it's made it narrower, okay? So it's basically gone from a normal graph to a bit narrower. That's basically what's happened. Has it been reflected? No, that's not applicable, no. And then it's been translated. Yes, it has been translated. 4 units in the negative direction and 11 units downwards. So how do we get that? This goes 4 to negative and 11 down. And it's still a positive graph, so it hasn't been reflected. So we go 4 units to the left and 11 units down. So that would be negative 4, 11. Let's find my y-intercept. We're going to let x equal 0. When you let x equal 0, I'm going to have y equals 2, 4 squared minus 11. 4 squared is 16. 16 times 2 is 32 minus 11. 32 minus 11. Y equals 21. So it is going to have a y-intercept all the way up here. That's 11, 22. So it'll be about here. 0, 21. Drawing this graph is going to be very difficult with a stylus, but it should be coming down. Oy, that's a very terrible graph. Do not draw your graph like that. That is absolutely shocking. Sorry, I just find it really hard to do on the stylus. So it should be nice and smooth all the way down here. I will try and get that in a bit better. So really, is you want to get a nice smooth graph. And so it turns around down here and goes up again. And that's better on that side. This is terrible on this side. This should be getting a bit steeper. That's better. I prefer that one. So you definitely will need an eraser and a steady hand. What I suggest doing when you're trying to graph these is to actually sketch it first. That was nice, wasn't it? And then put it around it. Should be -11 as well. And then you put your axes, then you can put your axes around it to try and make it fit like that. Anyway, I'm just going to keep on working off this one. So that is -11, I should say, because it's gone down there. How do we find the x-intercepts? That's what I'm really interested in. Well, to find the y-intercept, we know that we need to let x equal 0 because we know every x-coordinate there is going to be 0. Similarly, anywhere on this x-intercept, we know that the y-coordinate is going to be 0. So it doesn't matter. I know this coordinate is going to be x something, comma 0, and this is going to be x something, comma 0. So I need to find out what that is. So to do that, I just let y equals 0, because I know y is going to be 0. Let y equals 0, and we get 0 equals 2 bracket x plus 4 all squared minus 11. I'm going to add 11 to both sides. 11. I stuffed this up, but that's okay. 11 equals 2 bracket x plus 4 all squared. X plus 4. Okay, divide by 2 on both sides. It's actually going to be 11 on 2 equals x plus 4 all squared. And now, and I've ran out of room, haven't I? Of course I have. Sorry. Now, my last little bit is, just to continue on from that, I need to square root both sides. It's actually going to be plus or minus the square root of 11 on 2 equals x plus 4. So it's going to be -4 plus or minus the square root of 11 on 2 equals x. Now, what is 11 on 2? What is 11 on 2? 11 on 2 is, if you think about it, that's what we're talking about, 5.5 there. Think about the square root of 5.5. Well, it's going to fall between the square root of 4 and the square root of 9. 4 and 9 has a value of about 2 points. The square root of 5.5 would maybe be like 2.2 approximately. So therefore, the square root of 5.5 is approximately 2.2. Why do I care about this? Because it will help me determine where the value is. So really, I've got -4 plus 2.2, -4 minus 2.2. So I know it's going to be about 1.8, -1.8, and it's going to be approximately -6.6. So if I had a scale on this, I would know which side of 6 to put it on. Like if 6 was here and 7 was there, I'd have to go between that. 2 and 1, I'd have to go between -2 and -1, -6 and -7. But what I'll put in as my coordinate for it, what I'll put in for my coordinates there, go away, would be, it's not even raising. So for my x-intercepts, I would actually write, and expect these kind of answers. You are going to get some crazy ones. I would actually write this is going to be -4 minus, that's going to take me further, minus the square root of 11 on 2, comma 0. And this coordinate over here, I'm just going to cross it out, this coordinate over here would then be -4 plus the square root of 11 on 2, comma 0. And that is where my coordinates will be. I'm going to go through a bit of an easier one. If we've got y equals 3 bracket x minus 2 all squared minus 9. Have a think about this, what's happened to the graph. Okay, has it been dilated? Yes. By 3 from x-axis. So it's gone narrower. Has it been reflected? No, it is that way still. Has it been translated? So when we're talking about translated, we're talking about just moved. Yep, it's been 2 units in the positive direction of the x-axis and 9 units down. Now, I'm just doing this as a shorthand. If I had to talk about how it was translated, I'd say it's translated, I'd write it's been translated 2 units in the negative direction of the x-axis, 9 units in the negative direction of the y-axis. These are my short notes. I want to know where the turning point is. Therefore, the turning point is at -2, -9. Will it have x-intercepts? Yeah, it will be, because it's a positive. Whoops. It will be, because it's a positive graph and it's shifted downwards. So as long as it's shifted downwards and it's a positive graph, fine. If this was -3, it wouldn't, because -2, -9 might be like here, okay? And because it's positive, it's going to have to be something like this. Whereas if it was a negative graph, it would be down here and it wouldn't have any x-intercepts. So let's find our y and our x-axis intercepts. So we're going to let x equals 0 to find our y-intercept. And the equation was y equals 3 bracket -2 squared minus 9. So y equals Rainbow? 3 times 4, yes?
How is it the turning point -2 and -9?
Ah, should be +2, 9. Thank you. Gone the wrong way. That way. Is that what you were looking for?
Yeah.
Yeah, thanks for that. Pretty easy to do. I was just more thinking about the numbers and something else, so please excuse me. Thank you. That was really, really poorly done, but well picked up on. 2, 9. It'll be over here. And now I don't know where the x-intercepts are, but I'm just giving a quick graph to look at it. Thank you very much for that one. Just thinking about where I was going next rather than that. It's so easy to do. This goes the opposite way. Well done. -2, 4, that's right so far. Y equals, that's going to be 12 minus 9, 12 minus 9, y equals 3. So I can see straight away that I haven't done my graph correct here because it needs to intercept there. So the graph's going to have to be more like this. Okay, and I'm going to expect 2 positive x-intercepts. To find my x-intercepts, I'm going to let y equals 0. Because we always let y equals 0 to find it. Same thing with the straight lines. So we've got 0 equals 3 bracket x minus 2 all squared minus 9. Now, normally you get better numbers like this to work, trying to find x-intercepts. We're going to add 9 to both sides. That's all right. I've done it again. 9. Oh, these aren't nice ones. That's going to be 9 equals 3 bracket x minus 2 all squared. And then divide by 3. That's going to give you 3 equals x minus 2 all squared. This is going to turn into, and this is where a lot of people forget, it's actually plus or minus the square root of 3. Sometimes you'll end up with a really nice number here, and that's plus or minus 2. We'll do one of those after that. Equals x, oops, there's no bracket anymore, equals x minus 2. So now add 2 to both sides. So the actual answer is x equals 2 plus or minus the square root of 3. Now, if you think about what the square root of 3 is, it's like maybe, what, 1.4? So that kind of makes sense. So it will fall between 0 and 1, and 3 and 4 is where this would fall between. So then if you had to graph this, we've got all the information we know now. It's at +2, -9. And the y-intercept is at, what do we get? The y-intercept 3. Okay, and it's at -9, so it's going to have to be about here, because if that's -9, -6, 3, yep. So I'm just going to come on down, like that. It shouldn't be getting wider. It should be tapered a bit more. And with your graphs, you want to sketch them all the way, oops, that's really bad, all the way to the edges of them there. Okay, so I know that this is 2, -9. I know that this point here is 0, 3, my y-intercept. And I know that this point here is going to be 2 minus √3, because that's going to take me more on the negative side. And this is going to be 2, whoops, comma 0. That should be comma 0 bracket. And this should be 2 plus √3, well, according to 0. And then you've labeled your x-intercepts. All right. So let's try and just do one last one here. Let's do minus 18. Sorry, minus 18. No, I don't want to do that. We're going to do this one. If we're looking at this graph here, we're going to look at where the turning point is. It's going to be at 418. Think of the graph though. It's been dilated by 2 from the x-axis. It's been reflected in the x-axis because of the negative. Therefore, it's going to be like that. So it's made it narrower, and then it's made a narrow reflected graph. And then it's been translated to 4 units in the positive direction of the x-axis and 18 units up. So that's what I'm thinking. So I know, will this have x-intercepts or not? Well, it will. Even though it's at 418, because it's been reflected, it's going to have to come on down, like so. So I want to find my y-intercept. We let x equal 0. So we've got y equals -2 bracket -4 all squared plus 18. -4 squared is what? That is 16. Just do bid maths here. I've done my brackets. I already put 0 in there. Now I'm doing my indices. I just did that. -4 squared is 16. Now I'll do my multiplication. -2 times 16 is -32. Some people struggle with the maths there. -32 plus 18 is going to get me to, what are we looking at there? 14 there. Y equals -14. So therefore, 0, -14 would be where my y-intercept is. So that graph's way off because it should be intercepting like down there, because if that's the turning point at 418, it should be there. Let's also find where the x-intercepts are. So we're going to let y equals 0. It's going to be 0 equals -2 bracket x minus 4 plus 18. Minus 18 on both sides. Divide by -2. It now makes it positive. If this isn't positive when you have a square root, it means there's no intercepts. And we'll look at that one after this. Now I can square root both sides. Hey, it's going to be plus or minus the square root of 9. The square root of 9 is 3. We have a nice whole number this time. I don't have to worry about the brackets because I've actually square rooted this side too, and that's what it gets to. So that is going to be plus or minus 3. So that means x will equal, and I add 4 to both sides, 4 plus or minus 3. So therefore x equals 7 and 1. So that's where my coordinates are. So now I've got everything on here. I know that my turning point is at 418. Let's go there. That is 418. My x-intercepts is at 1 and 7. 3, 4, 3, 2, 1, 4, 5, 6, 7. You should note that the turning point, the x-intercepts are going to be both evenly spaced from 4 across, which makes sense. So I can tell that they're correct, by the way. And then the y-intercept is at -14. So if that's 18, -14 would be around here. So it'd be 0, -14. And then we can just draw, hopefully, a really, really, really good, no, I've already stuffed it up, parabola. Already stuffed it up. And why I've stuffed it up is because parabolas don't get less steep. They just keep on getting steeper. So that line should be Coming more like that. That's better, ignoring this line there. So, and this coordinate here would be 1, 0. And this coordinate here would be 7, 0. Please make sure when you're labeling these graphs, they don't do in the back book, but you do them as coordinates all the time. If you don't do those in year 11 and 12, you will lose points. You always need to list them as coordinates. So that's the one there that we have. Lastly, I'm just going to do a graph of this. If we have y equals 2 bracket x minus 3 all squared plus 4. If we have this graph, if you think about it, the turning point is where? The turning point is at 3, 4. Here, it's positive. That means it's going to be like this. That means you won't get any x-intercepts. We will have a y-intercept. I know that's 3, 4. And I'll just do my y-intercept. It's 9. 18 plus 4 equals 22. So really, I've already drawn that wrong. Why I've drawn that wrong is because I've actually said that this is 4. So if that's 4, that means this would be about 6, right? And it doesn't go through there. It goes through 22. So that's why I'm talking about that's wrong. So if this is 3, 4, 4, 8, 12, 16, 22, around here. Then I can just come straight down. Oh, did that bad. And then turning point, and then straight up, and that's terrible. This side's a lot better. This side's terrible. That's better. Anyway, I think you get the idea what I'm doing. 0, 22, we'll worry about the shape later. That's going to be 3, 4. Now, I just want to show you something with the math. Now, I know my x-intercepts aren't going to work, but let's just do it anyway. Let's let y equals 0 and just watch what happens. So if this happens, alarm bell should be ringing going, maybe it doesn't have any y-intercepts. And that's why I always talk about, let's look at the dilation, let's look at the reflection, and let's look at the transformations. Reflection and transformations are key to see if it's going to have x or y intercepts. So it's really important to think about where it is and how it's moved to see if it is. Because if this was negative in front, then it would have x-intercepts because it would be, reflected. It would go through here and it would go through here. So let's just let that equal 0. So it's 2 minus 3 plus 4. Okay. So it's y equals 2 bracket x minus 3 all squared plus 4. Now, if we let y equal 0, 0, that should be in here actually. I should actually write let y equal 0 there, not there because I haven't. 0 equals 2 bracket x minus 3 all squared plus 4, and minus 4 on both sides. Minus 4 equals 2 bracket x minus 3 all squared. Divide by 2 on both sides. It's going to be negative 2 equals x minus 3. What's the square root of negative 2? You can't do the square root of negative 2. There is no real solution. Why I say there's no real solution? Because someone made up this thing later on, which if you want to do specialist maths, which is the square root of negative 1 actually equals I, which is an imaginary number to overcome this problem. We're going to park that and leave that for you guys to get to in year 11 in specialist maths. There's no real solution to this because if I had like negative 4, it can't be negative 2 times 2 because negative 2 times 2 is negative 4, but they're two different numbers on the number line. And they need to be two identical numbers. You can't actually get any square root of negative 1 because one needs to be negative, one needs to be positive. You can do the cube root, though, of negative numbers because that can equal negative 2 because negative 2 times negative 2 times negative 2 because it's going to land on a negative. So any root that's an odd, you can actually do. So the problem here is that I can't square root it, okay? And you can't go, plus or minus the square root of negative 2. I mean, you can write that technically, but you can't solve it any further. There is no solution to that. So if you do run into that, think about, maybe it doesn't have any. And then when you think about its translations and dilations, reflections, and transformations, it will hopefully click and make sense. So that's where you just do your y-intercept with that. So I want to just go through the x-intercepts really today, and then briefly go over completing the square with you guys as well. So it's a bit of a carry on from yesterday. We're just trying to really just increase the understanding of that a little bit more. Sketch parabolas by completing the square. So you'll actually have to find the x-intercepts for these first few questions. And you will have tomorrow's lessons. I'm not here tomorrow. You will have tomorrow's lesson to go through this as well. So here you just need to determine the coordinates of its turning point and state whether it's a maximum or minimum. Maximum means if it's upside down has a maximum point, or a minimum. This obviously has a maximum and its turning point's at 2, 3. But later on, you'll need to determine the x-intercepts, if any of them, if any. And why we say if any is because it may be something like this, where it's the turning point's above it and, you know, it's not going to be there, or it might be below it and it's a negative case. So the time when you're not going to have any intercepts is if it's been reflected in the x-axis and the turning point is below the x-axis. So it's y coordinate is really what you're looking at of the turning point. Or if it is a positive graph, it hasn't been reflected, and the y coordinate is above the x-axis, then it's not going to come down, it doesn't intercept. And you're going to run into this dilemma and try and find the intercepts. You have the square root of a negative number. So you're going to go through these questions and basically try and do that for those ones. Determine the y-intercept for each of these, which we've kind of already, you should be able to work through and see what they are. And determine the x-intercepts, if any of the following. So again, have a think about what the graph looks like and would there be any? Would this have them? Yes, it would. Would that? Yes, it would. That one would. That one would. That one would. Yep. So just keep on working through these. This one obviously wouldn't because it's moved 18 up and it's still positive. It's happy. So it's not going to be there. This one won't because it's been reflected and it's below the x-axis. Then what you'll need to do is determine the x-intercepts by first completing the square and rewriting equation into turning point form. So this is the step we're going to revise for you guys. Just going to revise this for you. So we've got x plus 6x plus 5. So turning point form. And what turning point form is it is actually completing the square. And that's why we did all completing the square a while ago. So just as a refresher, when we're completing the square, the first thing you want to always do is take out the factor in front of x. If it's 1, it's fine. Once you take out the factor, you take it out from all of these things if you want. Then what you want to do is we then plus or minus basically 6 on 2. That's what you want to add to it, which is 3. So it's plus 6x plus 3 minus 3 plus 5. Now the shortcut, don't forget, is now this makes a perfect square. So that's going to actually make it into x plus, what do we got there? Oops, I should have squared this. That needs to be squared. Oops. So that needs to be plus 9 minus 9. The shortcut there is, that's obviously going to be plus 3 all squared. Don't forget you need to introduce round brackets if you do it inside the brackets. But the shortcut is basically you halve that, and that would be what this becomes squared. And the other one, because that is going to make x plus 3, this will factorize to x plus 3, x plus 3, just this section here. So really, it's just the half of that will become it. And then the square half and the square of it will be taken away from it. Minus 9 plus 5. Alrighty. And that is there. That's all in these brackets still, because I've got all these in the brackets, because if there's a 2 on the outside, then you need to multiply it out. Then I've got y equals, I'm still going to keep my brackets there just for the purpose, x plus 3 all squared, and then we've got, what's that, minus 4. Then if you had a 2 at the front here, it would actually turn into, if it did have a 2 at the front, it would turn into y equals 2 x plus 3 all squared minus 8, but it doesn't have that. So the first thing you always do is take out the factor of whatever this is, and you've got to take it out from each of them. Oh, there we go. Insufficient memory. From here, I now know that from here, I now know my turning point, where it is and what it's going to look like, and I can find out everything else from there. So that's how we complete the square. I'm just going to do one more for you. Let's do x squared minus 4x plus 14. So remember, you can include this or you don't have to in the brackets. So again, I halve that and square it. So it's going to be y equals bracket x squared minus 4x. Half of that squared would be 2. So I'm going 4 divided by 2 and then squaring it, which would be 2 squared, which is 4. It's going to be plus 4 minus 4 plus 14. This will make a perfect square of x minus 2 squared, which basically is the shortcut of halving that would just become minus 2. It always becomes that. And the plus 4 from that, minus 4 goes on the outside, always the minus section. The positive side always goes in that. That will always be the minus, because this will give you, like, basically you've got to add and subtract. The positive section always goes into this. It forms into that. The negative always sits on the outside. Minus 4 plus 14. So y equals x minus 2 all squared. What do we got? Minus 4 plus 14 is going to be plus 8. Do one more a bit quicker, and then I'll leave it to you guys. X squared minus 12x plus 5. I'll just make one up, actually. Y equals x squared. Let's go with minus 6x plus 10. Y equals, I know that's going to be x minus 3, so just half that. That goes into there. Half of that, 3, then I just square it. 3 squared is 9, so it's going to be minus 9, and it's always minus 9 plus 10. So y equals x minus 3 all squared plus 1. Therefore, if I want to graph this, I know a few things. I know my turning point is at is at 3, 1, 3, 1 here. I know my y-intercept's at 10, because it's, if I let x equals 0 here, it's y equals 10. And it has no x-intercepts. It's a positive graph. It's going to look like that. And that is at 3, 1. Should probably put it above, but anyway. And that's where we're going. Well done, I suppose.